welcome to the last group of sessions here at Universe 2019. Thanks for sticking with me. My name is Josephson. I'm a senior systems engineer at Expedia Group, and I'm going to be talking to you today about Expedia Group's ongoing project to consolidate all of our source code into a single instance of GitHub, and how we're using that to allow our developers to be more efficient and better collaborate with each other. So first, a little bit about me. I've been at Expedia Group for about 5 years. I'm a member of the developer collaboration team, and I primarily work on cloud design and architecture for our developer tools. That includes all new greenfield deployments, as well as legacy tool migrations out of our data center and into the cloud. When I'm not at work, you'll probably find me riding my mountain bike or playing soccer. So let's start with a little background. How do we get started on our consolidation project? Well, if we go back in time about 3 years ago, we can see that Expedia Group has been growing organically for a long time. We've added a lot of brands to the group, and in general, each of those brands has brought with them their own source code instance. That's been great. It's let our developers be very agile. They sort of have their own place to do their work. They can work quickly, do what they need to do, but they're also very siloed. They're generally working by themselves in their own place. They're not easily able to share code. They may not even know about all the other instances that exist out there. That also leads to decentralized administration. Different teams run all these instances. If you want to get access to one or permissions or learn something more about it, you have to figure out what team to talk to. You might not even know. All of these instances were also deployed in our on-premise data center. So that gave them limited connectivity to things like the cloud or external integrations. And we even had some systems that had an inconsistent user base, where the user directory for one system might not match the user directory in another, which just makes things like permissions even more difficult. So why did we decide to consolidate? Well, for starters, we want a single source of truth. We want all of our code in one place. We want our developers to know that if you're looking for code, you only have to go to one place to find it. We also want to give our developers a unified development experience. Across all these other systems, if you change teams or orgs, you might have to completely relearn how to just commit code into source control. We want our developers to be able to do things the same way no matter where they are in the company. We also want to be able to embrace collaborative development practices. We want our developers to be able to work together with each other, to find other teams' code, to contribute to it, to use it themselves. We want them to be able to easily find that and take advantage of it. And that's true for both inner sourcing and open sourcing. We want our developers to be able to both work with each other and contribute to each other inside the company, and also be able to be part of the greater community at large. And finally, we want to reduce some costs. We've got a lot of infrastructure for all these different systems. We got to license all of them. We got to have different teams administering them, and we have to train users to use them when they move around inside the company, or there's a reorg or something like that. So that sounds great. We can get a lot of benefits out of consolidating, but we hit some sources of resistance when we tried to start this project. So for starters, there's just plain organizational inertia. To a lot of developers, the current systems work just fine. You check out your code, you make your changes, you submit it, you deploy it. Everything seems good. It's difficult for the teams to see the immediate benefits of going through a large-scale migration like this. Going to a central system also requires teams to accept some compromises. When they own their own system, they can do whatever they want with it. They can fully customize it, make things work however they want. If they go to a central system, they're giving up some of that control, and they're letting another team make some decisions that may not always be ideal for them. There's also potential loss of historical metadata with any sort of migration project. We'll do our best to migrate everything over, get all their data, get everything they need, but it's always possible that we'll lose something in the transition. They're also going to lose ownership of their systems. They're not going to be able to control them themselves, have system admin rights, that sort of thing. They're giving all that up to another team. And it also just creates a lot of churn. You're changing a lot of things about your code pipeline. You may have to redo existing customizations or integrations. All of that has to take place before you can really take advantage of the new system. And finally, there could just be a lack of feature parity. The system they were using might not have the exact same features as the new system, or they might work in a different way. So how do we move forward? Well, for starters, executive sponsorship is always important for something on this scale. You need an executive that's willing to go out there and say, this is a useful project, this is important to us, it's worth the pain, we're going to actually make this happen. That kind of mandate is extremely helpful, but it can't be the only thing you do. You also need to make your new system awesome, make it great. Make it something that teams are going to want to use. If you give them some new features or better performance or easier connectivity or something like that, then it's going to be something that they want to switch to, and they're willing to accept the short-term pain of the migration. We also want to simplify the migration process. This is all about making it easy for our developers. We want them to be able to move from one system to another without it being some big drawn-out process. We want to make it as easy as possible for them to get their code in the new system and to start taking advantage of it. We also want to make as much of this self-service and self-owned as possible. Our teams love to have their own control over things. We want to allow them to do that, and we'd much rather that they solve their problems and they figure things out than they have to constantly come to the support team for it. So we want to do as much self-service and self-ownership as we can. We also want to have thorough, high-quality documentation, and we want to have it ready before the questions are even asked. We want to allow our developers to move quickly, to get on board with the new system, and to start using it. We don't want them to have to constantly stop, ask questions, wait for us to respond, that sort of thing. So we want to get them some docs, have them ready to go, make them easy to search and find so they can help themselves. And finally, it's important to listen. You're not the one that's likely going to be using your system the most. You're probably more of an engineering team. So pay attention to what your developers are trying to do. What are their challenges? What are their struggles? What are the things that they're having trouble with in their current system? And what can you do in your new system to make things easier for them? So we came up with a plan. It's pretty easy. We're going to build a new system. We're going to migrate all relevant code to it. Relevant is a bit of a key word there. We only want to bring over what actually matters. Tons of stuff builds up in source control over time. We want to leave all that junk behind. We want to just bring over what really matters, what's going to be used in the future. It's our chance to kind of get a fresh slate, clean slate. And finally, we want to enable our developers. We want them to be organized. We want them to be able to encourage and embrace collaborative development practices. And we want to make sure that we remove any roadblocks that are preventing them from being more efficient. So we started with the build process. We're going to build our all-new instance of GitHub Enterprise. So why do we pick GitHub Enterprise? Well, it's the industry standard. When you think about Git, you think of GitHub. It also has a common experience with GitHub.com. So anybody that's been working with GitHub.com is familiar with the user interface. They come to Enterprise. It looks the same, works the same, feels the same. It's something that everybody's pretty used to. It is already in use in parts of Expedia Group, so we have some organizational momentum there. We have some users that are already on board with it, happy with it, so it's easy to make the decision. And finally, it's familiar to most everyone. Developers coming out of college have probably been using it for the projects there. People involved in open source in their personal lives have been using it. It's something that isn't going to seem foreign to a lot of people getting started for the first time. And finally, we love that GitHub's dedicated to continuous product improvement. I mean, we've just seen over the last couple days that there's all sorts of new features getting added to GitHub every 6 months. We're really crossing our fingers that we get all that stuff in an enterprise server pretty soon. And we're also really happy about enterprise support. We like knowing that there's a team behind us that if we have problems, if something doesn't go right, that we can go to them, get the help we need, and move forward. So we came up with a list of requirements that we wanted our instance to have. First, we want it built in the cloud. Building in the cloud gives us easy scalability. We can turn up the resources if we need them without much pain. It lowers our costs. We only have to pay for what we need. And finally, we can use automatic and deployment configuration tools. We also want to make sure that we have a single endpoint and only a single endpoint. Some of our old systems had 6, 7, maybe 8 different proxy servers for different network locations and regions of the globe. We don't want our developers to have to deal with that anymore. That's a lot of configuration overhead, a lot of tribal knowledge they have to remember if they want to get the best performance. We want them to just remember a single address, and that's all they ever need to use. We also want it to be geographically available. We want it to be in multiple regions. We want intelligent routing of those regions so that the user traffic will go wherever they get the best performance. We also want it to be redundant so that if we have a problem in one region, we can easily fail over, keep going. Users may not even notice. And finally, it should be secure. We want our endpoint to be fully protected. We want a WAF in front of it, make sure that we're protected from malicious traffic, DDoS attacks, things like that. And we want to only allow trusted access. We want to make sure that only Expedia-owned and approved sources can access our source control. So we take those designs and put them all together. We get something that looks a little bit like this. It's pretty straightforward. You start at the top. You can see our user traffic coming in. We use Akamai for our IP whitelisting and geolocation services. Akamai will look at the incoming traffic, figure out which of our 3 regions will give it the best performance, and route the traffic there. All of our 3 regions then have a direct connect back to our data center, so we can still send webhooks to on-premise legacy systems. So what kind of user experience do we get with that design? Well, there's a single URL. There's only one address that our developers ever need to know. You get code, you always just go to the same place. Doesn't matter if you're in the lab, if you're in production, if you're working on the VPN or working at home, in the Chicago office, London, whatever. One address is all you ever need. And you also get automatic regional proxying from that. You use that one address, and Akamai will figure out the right place to send you so you get the best performance possible. No additional configuration needed. We also support HTTPS and SSH, so teams can use whichever authentication method works best for them. And it's responsive and fast. Since it's built in the cloud, we can easily just crank the knobs up if we need a little bit more horsepower. And finally, it's reliable. We have very little downtime, and upgrades with GitHub Enterprise are quick and very low impact. So we've got a new instance built. Now we need to migrate all our stuff to it. So what are we dealing with? Well, at Expedia Group, we got about a little over 10,000 active Git users. We've got something like 60,000 Git repos across both Bitbucket and GitHub Enterprise, hundreds of thousands of pull requests in those repos. We also have 15 Perforce systems, about 1,800 active Perforce users, and then minor amounts of code in Subversion, TFS, GitLab, and some other things. So some challenges that we face with this kind of a migration scope. Well, for starters, the migration process is different for each system. The way you migrate code out of Bitbucket isn't the same as you migrate code out of GitHub or Perforce. There's also a pretty big impact to our development teams with this kind of migration. Any existing automation or reporting systems will need to be updated for the new system. And there could just be differences. If you're working in Perforce, that's a very different experience than if you're working in GitHub. And finally, this kind of migration is going to have an impact to our teams. Your roadmap is going to be affected. Your release cadence might not be able to stay the same for a short time. There's probably going to be some impacts to milestones. There's also impact to our support team. Our support team isn't huge. If there's a lot of problems with migrations, they could get overwhelmed. They may not be able to keep up with the flow of tickets. If they fall behind, that's going to slow responses to teams, and that could slow our development teams down even more. And finally, there's just plain processing time. We're talking about a huge amount of data, and you can only move so much data so quickly. So at the very base level, we're just going to have to wait for all this data to move where it needs to go and get processed into the system. So what's our plan? Well, we want to automate as much as possible. Doing automated migrations means we can drastically lower the amount of manual effort is required from our support teams. We also want to allow our teams to migrate on their own terms. We want to make migration a self-service process for them. We want them to be able to decide when the time is right, make the choice themselves, and then execute the entire migration without having to contact us or the support team. We also want to make sure that we give our teams reasonable deadlines. So provide them the tools, let them self-service their migration, but give them a deadline that they have to meet and hold them to it. If we keep letting teams push things out, things are never going to get done. One of the great things about self-service migrations is that you're also going to let your teams test first. They can move over a repo, maybe two, check all their pipelines, check their CI/CD, make sure that everything is working with the new system, get everything ready, so when finally the time is right, they can push the button, migrate everything, and be ready to keep going. We also make sure that our migrations have easy-to-follow instructions. We want to make sure our instructions are clear and concise, that when teams are ready to migrate, they can follow the documentation, follow the steps, move the repos over, and everything works on the first shot. We want to make sure that we document anything that gets asked frequently so that all the answers are right there waiting for them and they don't have to come to us. That said, if they do have problems or have questions, we want to have a dedicated support contact point. We want to make sure that if teams have problems, if they need to get a quick answer, we don't want them to have to look through some service directory or some sort of ticketing system or something. We want them to be able to get to someone quickly that has the information they need so they can answer their question and move on with their migration. So what did we do for automated migrations? Well, for us, we were able to support them for GitHub Enterprise and Bitbucket. We use two different utilities for that. First is GHE Migrator. This is the native GitHub import-export tool. It's included on every GitHub Enterprise appliance, and you run it on both the source and the destination. So if you're coming out of GitHub Enterprise, you run GHE Migrator to export the repo, transfer that to your destination GitHub Enterprise appliance, and then GHE Migrator again to import it in. BBS Migrator is for Bitbucket, and that is a GitHub-developed Bitbucket export tool. It exports your repo data through the Bitbucket REST API, and it generates a GHE Migrator-compatible repo bundle, which means that you can take your repo bundle, export it out of Bitbucket, copy it to your appliance, and then run GHE Migrator to import it. And the combination of these two utilities covers about 95% of all Expedia Group repos that needed to be migrated, so this is where the bulk of our automation efforts were focused. So what are the challenges of trying to automate these migrations? Well, for starters, these migration tools require high-level permissions. They're generally command line utilities. Then GHE Migrator is meant to run on the GitHub appliance itself, so you need root-level access there. And BBS Migrator requires system admin permissions in Bitbucket. They're also a manual process by default. These are just command line utilities that take a bunch of parameters. It's not the sort of thing that's been designed to be automated. These tools are also generally meant to be used asynchronously. So the export process is completely different from the import process. So you have to have some way to communicate from the export to the import and make sure they stay in sync with each other. And it's also a serial process. GitHub only allows one instance of GHE Migrator to execute at a time. So that means that the speed that you can import repos into GitHub Enterprise is limited by how fast you can execute GHE Migrator. And it's also difficult to parallelize these migrations. While it is possible to batch repos into GHE Migrator, you have to use a single conflicts file during conflicts processing for all of those repos, and that can make doing that with automation pretty difficult. So let's go into a little more detail about conflicts processing, because this is one of the trickiest parts of dealing with these migrations. Conflicts processing is basically where GitHub will compare the incoming metadata from your repo that you're importing to what already exists in your destination. So it's looking at things like users, teams, orgs, anything that would collide. GitHub will generate a conflicts.csv file, and it'll list out all of the things that are a conflict between the source and the destination, and then allow you to tell GitHub what you want to do with that conflict. You can use this to map things together if they're the same. You can rename things. You can remove things. It's a pretty powerful and flexible tool, but it needs to be customized to every repo that you're importing. So you can't use a general set of settings for every repo that's coming in. It's also something you have to be very careful with. If you do something wrong in the conflicts file, you can easily import 400 user accounts that you didn't mean to, or a whole bunch of teams that do nothing. It's a really good way to pollute your nice new GitHub Enterprise appliance with a bunch of garbage data that can be a real pain to clean up afterwards. So generally, definitely use it carefully and test everything thoroughly before you try to use it in production. In our specific case, one of the most difficult things to handle was when we had inconsistent user bases between our source instance and our destination instance. So this means that the user directory that the repo is coming from is different from the user directory of our new GitHub Enterprise appliance. So this would mean that if the user J. Smith, for example, existed in the source and existed in the destination, we couldn't be confident that they were actually the same person. It could also be the case that even if J. Smith didn't exist in the destination, he might someday get hired. And if they did, then they probably wouldn't want to log into GitHub for the first time and see that they had 400 commits under their name from 10 years ago. It's the kind of thing you don't want to run into in the future either. So our solution to this problem is that whenever we import repos from a system that does not have the same user directory, we rename all of the users coming in with a special tag that shows where they came from, but also make sure that we never have any username conflicts with our destination instance. We've also done something similar with importing teams, since in general the teams on a source instance are not going to exactly match up with the teams that the users want on the destination. We basically consolidate all teams being imported down to a single placeholder team and then allow our developers to create their new team structure as they need to in the new instance. So to handle all of this automated migration, we created something we call GUS. GUS stands for GitHub Self-Service. This was developed by Expedia Group and essentially wraps the existing migration tools to allow their use by non-admins. With GUS, our users can do one-click migrations of repos from their source instance to their destination instance. GUS is written in Python, uses Jira for tracking and notification, uses an S3 bucket for repo storage, and it has a cron job on the appliances to handle scheduling. So this is the flow chart for GUS. This kind of lays out the processes that it takes. And you can see that there's only a single user interaction for this entire flow chart. In the top left, you can see it says user completes GUS migration form. That's the only thing the user ever does for this entire process. The user fills out the migration form, clicks the go button, and they're done. GUS takes it from there. GUS will check their input, make sure it's valid, check their permissions, make sure they're allowed to migrate the repo. It'll create a Jira ticket for tracking, and then it'll export the repo from either GitHub Enterprise or Bitbucket. Once the export is complete, it'll transfer the bundle up to S3, and it'll update Jira ticket to say that the export was successful. From there, the second half of GUS takes over on the destination GitHub appliance. It'll download the repo bundle from S3, process conflicts on the repo, and generate a custom conflicts.csv file. And then it'll import the repo into GitHub using that custom conflicts file. Repo will be unlocked, the Jira ticket will be resolved, and the repo is ready to use in GitHub. If anything happens along the way that goes wrong, if there's an error or something like that, it'll update the Jira ticket with the error details and escalate it to our support team for them to take a look. So we can look at a screenshot of GUS. This is what it actually looks like. Text is a little small up there, but that's OK. You can see there's some documentation, some links to our migration stuff up there, some instructions if people don't want to read the documentation, and some simple boxes at the bottom. If you want to migrate a repo, you paste in your repo URL, select a GitHub org to send it to. You can put in a repo name prefix if you want, and your email address. And that's it. Click the green button, wait a little bit, your repo magically pops out in GitHub, ready to go with all of its history, all of its pull requests, all of its metadata, everything that it needs. One of the cool things that our engineer did with this is he worked to mimic the user interface of GitHub itself in the migration tool. So GUS looks very similar to GitHub. It really helps tie the migration process together with the new system that our users are going to be using. And you can also see up at the very top, there's a couple other tabs up there. We've even extended GUS since we created it and given it some additional self-service functionality to handle things like org creation and a permission viewer. So some stats on using GUS. Well, so far we've migrated over 5,500 repos. With GitHub Enterprise, we see 99% success on our first migration attempt. With Bitbucket, we see about 90% success. Though in the last couple of weeks, we've even been able to shove that number up a little higher by doing some things like reducing latency between GUS and our Bitbucket servers, and also making sure that GUS has enough resources to handle exporting our largest repos that are in Bitbucket. Our average migration time for repos for GitHub Enterprise takes about 15 minutes. Doesn't matter how big the repo is. For Bitbucket, takes 30 minutes plus an hour for every 1,000 pull requests. And the main reason that Bitbucket takes a bit longer is everything's being done over the REST API. So there's pagination involved if you got a whole lot of data coming out. There's a lot of HTTP overhead, things like that. It just takes a bit longer. One of the cool things that is an example of the collaboration we're hoping to see more of from going to GitHub is originally we wrote Gus to only migrate a single repo at a time. It just has you paste in one repo, click the button, that's it. Well, one of our dev teams took a look at Gus, figured out the right way to submit an HTTP request to it, and figured out that it was possible to script submitting migration requests to Gus. So they were able to write up a list of all the repos they wanted to move, make sure they were ready to go, and then write a script to submit them all through Gus all at once. They'd queue up 100, 120 different repos to migrate, and Gus would just chew through them over the next period of hours. This script was done pretty much without our interaction. They came to us and said, hey, we wrote the script and it migrates our repos. They said, that's awesome. Give it to us. Let's get it on our site. Let's share it. We've since had a lot of other developer teams that have been using the same script, enhanced it with their own requirements. It's been a great way to allow our teams to move things over in bulk once they're ready to go without having to go through the user interface a whole bunch of times. So we can look at some of the statistics of migrating things with Gus. So I know the numbers are pretty small in here, and that's OK. The shape of the line is really the more important thing here. This is showing our migrations over time. The red line is migration requests created. The green line is migration requests completed. And you can see that when we first introduced Gus a little over a year ago, we migrated our first instance pretty quickly. We did about 2,500 repos in about a month and a half. Things slowed down for a little bit after that. And then you can see at the beginning of this summer, we added a couple more instances to Gus. And our repos migrations have taken off again. The really cool thing about this graph, though, is that you can see that the two lines track very closely on top of each other. And that really shows the impact of our automation and how successful it's been. We can clearly see that a migration request comes in, Gus migrates it, Gus closes it, moves on to the next one. We're not seeing a lot of waviness where Gus was struggling or having problems. We can look at the same data in a slightly different form if we look at the non-cumulative graph. And it looks a bit more like this. So we can see that this is the same thing again. Red line is migration requests created. Green line is migrations completed. And you can see that the two lines have basically the same pattern. And that just shows us that even when we get up to 100, 120 migration requests in a single day, Gus is doing its job. It sees them, it migrates them through, chews through all the migrations. We don't see a lot of impact to our support team from it. So that's great. We've got our automated migrations, but that doesn't cover all of our code bases we're trying to centralize. So we have some other migration methods as well. We call them assisted migrations. This is if you're migrating from github.com or Perforce. This still includes your full history, all your pull requests, all your issues, projects, things like that. But they have to be scheduled with our support team. So it's something that takes a bit of effort on our part. There's a bit of manual work involved. But these could be automated through Gus if they became a requirement. We don't have a whole lot of code in github.com and Perforce is moving over, so we haven't done that yet. But it's always an option. And finally, there's just a plain old manual migration, basically just doing a git clone and a git push. Anybody can do that. It doesn't require anything from the support team. It's totally self-service. You still get your full commit history. You just don't get pull requests or issues or other metadata like that. But it's a great thing to use if you're just moving over a test repo, a hackathon repo, a sandbox repo, something like that. So we migrated our code over. We've got our new system online. How do we get our developers to be more efficient and to collaborate with each other? Well, for starters, we want to get organized. First thing we did is we created some standards for how we're going to use GitHub organizations. We disabled the ability for users to create them by default, and we wanted to make sure that orgs were used thoughtfully and carefully because we didn't want to wind up with a whole bunch of clutter in our brand new GitHub instance right off the bat. So we published some standards for when an org is a good idea, when it's not, and we've limited creation of orgs to our senior level engineers and above so that there's some thought that goes into creating one, and it's not something that just spur of the moment somebody can throw up if they decide they want to. We've also tried to set some source control standards for our developers to meet. We want to make sure that they use good naming conventions for things like organizations, repos, and teams. We also want them to use discoverability aids, so write good README files, use repo topics, things like that. And we want our developers to use branch protection features. We want to embrace a pull request-driven model. We want to make sure there's code review on everything. People are looking at things and giving their feedback. And we want our developers to define a contribution process to the repos. Make sure they're adding a contributing.md file that lays out what the code that they're using is, how they expect it to be used, what kind of standards they want it to meet, things like that. We want to make sure our repo maintainers are clearly noted and clearly identified and that they're paying attention to their repos. And we want to make sure that our developers are all comfortable working with pull requests and forks, since those are primary means of doing collaborative development. So how have we tried to encourage collaborative development? Well, we've created an internal inner and open source foundation at Expedia Group. This is a team that has broad representation across the company. It's not limited to any one brand or any one part of the company. And their mission is to develop standards and best practices for code development, collaborative development, working together, things like that. They're also there to try and communicate the message of collaborative development. What are the benefits that can be gained from it? Why is it valuable? Why is it worthwhile? Why is it something we should be trying to do? They also try to foster a bit of a community, get people talking about working together, get people sharing stories, things like that. One of the things they've done is set up what we call lean coffee sessions. These are basically informal meetings between developers on different teams that happen sort of spontaneously at our offices around the globe. And the point is just to get together, talk about what you're working on, talk about your challenges, what you're trying to figure out, talk about the things you've learned lately or the new tools you found or a great new framework you're working with or something like that. Basically just a way to get people more familiar with some of the challenges and issues facing the development teams that may be right next door to them but they never talked to before. And finally, we've done some hackathon and roadshow days in conjunction with GitHub, where we've gone to our corporate offices, put on a series of talks and demonstrations of GitHub and what it can do, and then even got our engineers involved in a hackathon to get their hands on with GitHub and learn how to actually take advantage of some of its more important features. Finally, we also want to make sure that we celebrate our successes with collaborative development. This is a big shift in development for us. It's something our developers weren't super familiar with before. We want to make sure that people know when it's gone well, know when it's been a good idea, and when things have worked out for them. So write some blog posts about it. If you found someone else's project and you used it and it worked really well, make sure people know about that. Make sure people know that you worked together with them and that it really saved you time and effort and that sort of thing. It's also great to bring these things up in product reviews of leadership. Leadership loves to hear when things have gone well and you've done good things. So make sure they know about it. Tell people that I worked with this developer in the other side of the continent, and we came up with this project together, and we both had a need and we both made it happen. Make sure that people know that you've had that kind of success with collaboration. And we also want to make sure that teams don't just have plain roadblocks blocking them from trying to work in a collaborative model. For starters, it seems really simple, but use a public repo. A lot of our developers were pretty used to sort of owning their space, and they tended to work in a private repo. They tended to do things on their own, out of the eyes of everyone else. A big change to that is just merely flipping your repo to public and being okay with everyone else seeing your code and everyone else seeing what you're doing. Another part of that is to get used to working with a fork-based reflow. Using a fork on a public repo means that you can commit pull requests back to that source repo without even needing write permissions on it. That's a common paradigm in the open source world on GitHub.com, but it's something our developers haven't been very familiar with so far. It's also important that our developers are open to outside ideas. In the past, they've really owned their systems themselves. They felt like it was their thing to decide how it was used, dictate what people did with it. But that's something to really get away from in the collaborative mindset. It's really important to avoid an ownership mindset. If you're maintaining a repo, you're really more of a guide of that repo. You're there to make sure that it moves in the right direction, that people are making worthwhile changes to it, but you don't really control and dictate exactly how people take advantage of it. It's good to kind of think of yourself more like a park ranger. If you're going to a national park, the ranger doesn't own the park. He doesn't tell everyone exactly what to do there. Instead, he's just there to make sure that you take advantage of the features of the park in a safe way, that he keeps the place tidy, that keeps it ready for the next person. And finally, make sure that our developers review their pull requests promptly. There's nothing worse than finding a repo out there that can really help you. It needs a 2-line change to make it work with your environment. You submit a pull request, it's really simple, and then you hear nothing. 2 weeks go by, nobody's gotten back to you. It's just the worst thing. You really want to use their code. You don't want to just completely fork the thing yourself, but nobody will get back to you about wanting to ever merge your pull request. So pay attention to your pull request, provide honest, unbiased, and helpful feedback, and do it quickly. So how do we measure success? How do we know if this project has been successful? Well, for starters, we're using something called Autodesk Hubble. Hubble was demonstrated here at Universe a couple years ago. It's essentially an application that crawls your GitHub instance, and it generates statistics of your development activity. So it'll create some reports on all of your practices, and things like contributions to orgs, total contributors, pull request usage, fork usage, system activity. There's tons of different statistics that it has. It's a free application. It's on GitHub. You can go download it yourself and turn it loose on your own GitHub, and you might find something out. Specifically, we're really interested in the collaboration graph. So it looks like it's just a whole bunch of colors, a bunch of lines and everything, but it's actually showing when our developers are contributing to organizations outside of the sort of home org that they normally live in. So as we see more collaboration, we should hopefully start to see more and more of these lines connecting different segments together. As it stands right now, this is the actual graph from Expedia Group GitHub at the moment. And if we zoom in a little bit on one org, we can see that org 1 here has seen a little bit of collaboration. They've contributed to a few other organizations, and they've received a contribution from another one. So it's a good start, and we hope to see more of that in the future. So what kind of lessons have we learned from doing this whole thing? Well, for starters, avoid some things to avoid. Avoid overly rigid thinking. It's really easy to get fixated on trying to do things perfectly, trying to come up with the absolute best of everything and actually doing things the perfect way all the time. And that's just unrealistic. You really can't expect everyone to be able to work the same way. Teams have different needs, different requirements, different skill levels. You're going to have teams that are technically advanced and teams that are a bit more behind the times. And you still need to support all of them. Your system still needs to support all of them. So it's important that you be flexible, be willing to adapt to what your teams need, and don't get caught up on trying to be the absolute latest and greatest all the time. Second, make sure that you listen to your users. Your users are the ones that are having to deal with what you've given them. So pay attention to their sources of friction. What are their unique challenges? What are the things that they're trying to do that they can't do right now? Or what are the things that are hard for them to do right now? Listen to them and see if you can do something to make their lives better, to make things easier for them. It might just be that a small tweak to your design will make things so much easier for them. Or it can even be that they just aren't aware of a certain feature in GitHub. And if you explain it to them and how it works, have a face-to-face conversation, you'll be able to get them started on the right foot, and they'll feel much more confident and comfortable with migrating to a new system and having to move all their code over. Basically, ignoring your users, you could miss out on some really big wins. And those can be some of the best things to celebrate, is if you find a problem that they've had, solve it for them, and then they're more efficient as a result. And finally, you don't want to ignore reality. We all have technical debt. It's a thing. It exists. We don't like it, but we all have to deal with it. As much as we'd like all of our developers to be writing microservices that are containerized and auto-scaled and all that sort of stuff, it just doesn't exist. Everybody isn't ready for that. And it's something that you just can't expect. So pay attention to your technical debt, make sure that you've addressed it and that you're supporting it and that your system isn't leaving behind some of the legacy teams that are still maintaining code that is critical to your business. Now, that said, you also don't want to try to cover 100% of every use case. You're going to have those teams out there that have just never had a good reason to change their practices. They're still using some old waterfall deployment process. They're still using some awful batch file script deployment system or something like that. They have no way to pass OAuth tokens to GitHub in a secure way. Those are the teams that you're going to want to really talk to, because you probably don't want to compromise your design to support what they're trying to do. The migration project you're trying to get started could be the thing that finally pushes them to make some changes. Maybe they finally need something that they can't physically do anymore to get them to move on and join the modern world. So some key takeaways from this whole thing that we've been working on. Well, for starters, these migrations take time. We've been going at this for almost 2 years now. It's probably going to be another year, maybe even 2. It's a long project. There's a lot of stuff going on, so be ready for that. So as part of that, you want to set reasonable deadlines for your users, but you want to hold them to it. The worst thing is when you try to say, OK, let's get this done by May 1st, and then April 30th comes around, and they go, oh, yeah, we didn't get started on that. You're never going to get done if you let that stuff happen too often. It's important that you get teams involved, get them the information they need, make sure they can move forward, and then hold them to a deadline to make sure they actually get it done. Also, automate and self-serve as much as possible. The more you can get teams doing the work for migration themselves, the less you have to do. So put your legwork in up front, get your migration tools in place, get your automation in place, get your documentation in place, and you'll let teams be able to just do it on their own. Things just happen while you're sleeping. It's great to leave work one day and come in the next and find that 200 repos got moved into GitHub overnight and you didn't lift a finger. Also, find ways to encourage passion and excitement with your project. New systems can be cool. They can be exciting. Like getting frustrated and bogged down with some old system that has horrible network connectivity or poor performance or something like that. Like, find a way to get your users excited that they're going to have something new that can do cool new things. You know, if you come to Universe and you see some great features added to GitHub, communicate that to your users. Make them realize that, hey, when we get onto GitHub, you're going to be able to do this, this, and this, and you can't do that right now. Anything you can do to get users to get excited about the project you're doing, get them talking to their coworkers about how much better it's going to be when they move to the new system, that's nothing but a good thing. It just helps people get on the same page as you and be willing to move forward and make the changes that are necessary to make a project like this a success. Keep management up to date with successes. The executive that made the decision to make this all happen in the first place, he's going to love it when you get to go to him and say, hey, that big decision you made, that thing that you took a risk on, it's paid off. We've done all of this. We've made all these things happen. Everybody is this much more productive. We've been able to deploy this much faster. You know, whatever it is, whatever you've got to communicate how great things have been, make sure they know about it. They love to hear when their decisions have led to good things. That said, make sure they know about your challenges too. These kinds of projects always come with conditions. There's always things that you're trying to figure out that you're still working through that aren't ideal right at the moment. Make sure they know that you're working on them, so they know that you're making progress, but that you have a path forward and you have a process to make sure that you solve the problem and that you can move on. And finally, keep your head up. These projects are huge. There's so many teams involved. We've literally been talking to people across the entirety of Expedia Group in every office we have, trying to make sure that we can get them on board and that they're able to move their code over and that all of their deployment systems and integration systems and build systems are all working correctly. It can be really easy to kind of get bogged down and start to worry about how we're ever going to accomplish this for everyone, how everybody's ever going to be happy. It's a long project, but keep moving forward, pay attention to what your users want and solve the problems, talk to them and stay on the same page as them, and you'll find that you'll just keep moving on, and that graph I showed you earlier will just keep creeping up. Things just keep moving forward. So be confident, know what you're doing, and take care of things for users, and everything will turn out fine. So that's all I have for today. If you have any questions or comments, feel free to come up afterwards. I'd love to talk to you, and if not, you can shoot me an email, something like that. That's all I have. Thanks.